So we are talking about hybridization theory, and we have to talk about that. First, we will see about valency bond theory. Please be online while we transfer your call to one of our executives. Please be on. Hi. Hello. We talked about the valence shell electron pair repulsion theory to know about the shapes of molecules. Do you remember that?
Yes, sir.
Yes. Now we see this VBT proposed by Linus Pauling. Actually, hybridization theory was developed by Linus Pauling. Hitler and London and so many other workers developed VBT. Now, according to VBT, covalent bond forms due to overlap of atomic orbitals. Sir, what is overlap? Falling one over the other. Which atomic orbitals overlap? Only AOs which have an unpaired electron with opposite spin can overlap. The overlap can happen axially. Axial overlap gives stronger sigma bonds. Lateral overlap gives weaker pi bonds. Also, PP overlap is stronger than SES overlap. Why like that, sir? Let us look at that. If you look at the electronic configuration of chlorine, it is 1s2, 2s2, 2p6, 3s2, 3px2, y2, z1. In chlorine, there is a
Sir, you are muted. Sir, you are muted.
Sir, you are on mute, sir.
Yeah, yeah. I think now this is clear. Somebody erased what I wrote. Okay, sir. If I am looking at some people are getting admitted, no, in between if they get admitted, it is a disturbance. ఏంటి చూడాలి ఇప్పుడే రీచ్ 10 నిమిషాల్లో వచ్చాక రెండు స్పీడ్ పోస్ట్ కొరియర్ రెండు అవదాల తర్వాత ఓకే సార్ ది chlorine is having a unpaired electron in 3p-Z orbital. Another chlorine is also having an unpaired electron in 3p-Z orbital. These two orbitals overlap and you got a Cl-Cl bond. Suppose you have a hand, right hand, which is free, left hand you kept with some bag. Your friend right hand is also free. Now both of you can give shake hand. Any problem, sir? You can give shake hand always right hand with the right hand. Try to give a shake hand using your right hand and your friend's left hand. You can't. This overlap can happen only if they have same orientation. If they differ in orientation, orbitals cannot overlap. Are we very clean on that, sir? Now let us look at the formation of H2O. In H2O, oxygen is the central atom whose atomic number is 8. Electronic configuration is 1s2, 2s2, 2px2, y1, z1. So if I draw the diagram, this is 2s orbital that has 2 electrons not involved in bonding of oxygen. It is 2pz orbital that has 2px orbital that has 2 electrons not involved in bonding. It is 2py orbital that has 1 unpaired electron, and it is 2pz orbital that has 1 unpaired electron. This is the diagram of oxygen. 2s, I used a red color. 2px2, I used yellow color. 2py1 green color, 2pz1 blue color. Can you see it clearly, sir? Hello?
Yes, sir.
Now, if this 2pz orbital overlaps with hydrogen, which has a 1s orbital having unpaired electron, I got a sigma sp bond. Similarly, another hydrogen overlaps with the pz orbital. So I got water. In water, there are 2 bonds. They are sigma sp bonds. And what is the angle between the p orbitals, sir? How p orbitals are separated in oxygen? What is this angle?
104.5 degrees.
No. P orbitals arrange themselves at 90 degrees separation. Angle between px and py and pz, all 90 degrees, 90 degrees. So in water, the bond angle is supposed to be 90 degrees according to valency bond theory. But unfortunately, experiment says bond angle HOH in water is 104 degrees 31 minutes. So valence bond theory failed to explain the actual bond angle in water. Are we clean about that, sir? Hello? Yes? Yes, sir?
Yes, sir, clear.
No. Let us look at the formation of ammonia. Nitrogen is the central atom whose configuration is 1s2, 2s2, 2px1, y1, z1. This is 2s2. it is having 2 electrons not involved in bonding. It is 2px1, it is 2py1, and it is 2pz1. Now they have one unpaired electron each. Now when they are overlapping with a hydrogen s orbital, you got NH3. What is this angle between H and H? This is the angle between p orbitals. It is supposed to be 90 degrees. But in ammonia, bond angle is found to be 107 degrees 28 minutes. So the valence bond theory could not explain the bond angle in ammonia molecule. Are we very clean about it, sir? Hello?
Clear.
Yes, sir.
So the valency bond theory says that the axial overlap of orbitals gives sigma bonds. Lateral overlap of orbital gives pi bonds. The first
Sir, why
bond formed,
PP bond is stronger
the
than
first
sigma
bond
bond?
formed between any two atoms is sigma bond. The second and the third bond formed are pi bonds. Sigma bond is formed by axial overlap, pi bond is formed by lateral overlap. Let us see how it forms. Let us look at formation of O2. Oxygen electronic configuration is 1s2, 2s2, 2px2, y1, z1. It is your oxygen atom, 2s2. I am looking only at valence orbital, 2s2 and 2px2. I don't require these two because they have electron pairs. It is 2py1 and it is 2pz1. Can we see it, sir? Oxygen I have written diagrammatically. 2s I gave red color, 2px2 I gave red color, y1 is in yellow color, z1 is in green color. Are you seeing them clearly, sir? Hello? Are you
Yes,
seeing
sir.
them? Now this oxygen atom overlaps with another oxygen atom. This is another oxygen atom's 2py orbital. It is another oxygen atom's 2pz orbital. Notice that these two orbitals have electrons with opposite spin. And orbitals are overlapping. When the orbitals overlap, I got a axial overlap, that is sigma bond. This is the lateral overlap. By bending of the orbital, it is pi bond. The first bond formed between any two atoms is sigma. The second bond formed between them can be pi. Let us look at the formation of nitrogen. Nitrogen configuration is 1s2, 2s2, 2px1, y1, z1. So it is 2s2. I don't require this because it is electron pair. It is 2px1. It is 2py1. It is 2pz1. One electron. Now this is another nitrogen's 2px1. It is another nitrogen's 2pz1. It is another nitrogen's 2py1. First bond is no doubt sigma bond. Now this and this laterally overlap. This and this will laterally overlap. The lateral overlap will give weaker pi bonds. The axial overlap will give stronger sigma bonds. Can you see how this molecule is having electron cloud? The sigma electron cloud is symmetrically distributed around the internuclear axis. The pi electron cloud is lying above the nitrogen atoms. Okay, can you see it clearly how it is? I will draw a diagram again. This is sigma electron cloud between the two atoms, and it is pi electron cloud and it is another pi electron cloud. Oh, let's change the color. Can you see how it is looking like, sir? Px, Px overlap, Py, Py overlap, Pz, Pz overlap. Is it very clear, sir? It is Px orbital. It is Px orbital. Axial overlap gives sigma bond. This is the electron cloud in sigma bond. It is Py overlap. Py. The Py will overlap laterally. It is pi bond. It is another Pz orbital. The Pz overlap laterally. This is another electron cloud. So pi electron clouds are lying above and below the plane of atom, whereas sigma electron cloud is lying on the axis of these two atoms. Can you see it clearly? Hello?
Sir.
Yes, sir.
Hello? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
The topic under discussion is covalent bond. A covalent bond is formed by overlap of orbitals. Two atoms orbitals overlap if they have unpaired electrons. If these electrons have opposite spins. The first overlap between the orbitals of two atoms is sigma axial overlap. If there is a possibility, there can be second and third overlaps. They are pi bonds. Sigma bond is stronger, pi bond is weaker. If the overlap is happening between p orbital of one atom and p orbital of another atom, that bond is stronger because p orbital has a direction. This is stronger than sigma sp overlap, which is stronger than sigma ss overlap, which is stronger than pi overlap. Sir, if you are looking at s orbital, it is like a ball, it is like a sphere. Can you make one ball sit over another ball? Can you do that?
No, sir.
Because the s orbital has no direction and it is spherical, SS overlap is weaker. Because p orbital has a strong direction, it is like a dumbbell. It can effectively overlap with other p orbital. So sigma pp is always stronger than sigma sp overlap, which is stronger than sigma ss overlap, which is stronger than pi. So what is the difference between a sigma bond and pi bond? A sigma bond is formed by axial overlap, a pi bond is formed by lateral overlap. Sigma bond is the first bond formed between any two atoms. And the second and third bonds formed between atoms can be pi bonds. Sigma electrons are located exactly in between the two atoms on the axis. We say the sigma electrons are exactly in the center of these two atoms on the axis. I say sigma electrons are localized. They have a particular locality. Pi electrons are delocalized. This bond is strong. This is a strong bond. It is a weak bond. Can you see the difference between sigma bond and pi bond? Hello?
Yes, sir.
Yes, sir.
Sigma bond is formed due to axial overlap of atomic orbitals. It is the first bond formed between any two atoms. The sigma electrons are localized. When there is a sigma bond in the electron cloud, there is no place where you can't find the sigma electron. They are just like that between the two nuclei of the bonding atoms. Whereas if you are looking at pi electron cloud, the pi electron cloud is lying above and below the atoms. On the plane of atoms, you can't have pi electrons. A place where there cannot be any electron is called a nodal plane. Pi bond has a nodal plane. Sigma bond has no nodal plane. Pi bond is stronger. Sigma bond is stronger. Pi bond is weaker. Why pi bond is weak? Because it has a nodal plane. What is a nodal plane? A plane where there is no possibility of finding electron. Can we see the difference, sir? Hello? Hello?
Yes, sir.
It is a 2-bar question in IP. Write any 4 differences between
Sir.
yes, sir. Now,
Unable
what
to
is the correct order of strength of different bonds? Means sigma PP is stronger than sigma SP is stronger than sigma SS is stronger than I bond. Are we very clear about it, sir? Hello?
clear, sir.
Yes, sir.
This valency bond theory has some defects. Let us look at the case of BeCl2. Beryllium has an electronic configuration of 1s2, 2s2. How many bonds beryllium is supposed to form?
2.
0.
Bond.
Why beryllium valency is expected to be 0? Because no unpaired electrons. But excited beryllium atom has a configuration. So it is the 2s electron. It is the 2p x electron. When this beryllium combines with chlorine, chlorine configuration is 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. The pz orbital of chlorine overlaps with px orbital of beryllium. It is sigma pp bond. Now the beryllium s orbital overlaps with another chlorine's pz orbital, something like this. Notice that this bond can be anywhere because s orbital is spherical, but this bond must be like this. So in BeCl2, according to valence bond theory, one bond is formed by sigma pp overlap, one bond is formed by sigma sp overlap. One bond must be stronger and longer, one bond must be weaker and shorter. This angle between Cl, BeCl must be how much? What is the bond angle, sir?
130.
Notice that the second bond can be anywhere because it is formed by overlap of s orbital with p. So it can be like this, it can be like this, it can be like this, it can be like this. Because this s orbital has no direction. S orbital has patamalu, pillalu, pillalu, patamalu. So BeCl2 shape is not clear. It can be have any shape. The Cl-BeCl bond angle can be anything because one bond is formed by sigma pp overlap, one bond is formed by sigma sp overlap. S orbital is spherical, it has no particular direction. Are we very clear, sir? According to valency bond theory, in beryllium chloride, one bond is sigma pp overlap, one bond is sigma sp overlap. So one bond must be stronger, one bond must be weaker. The bond angle can be anything. Yes, sir. Hello. Hello.
Yes,
Are
sir.
we clear about what we are talking, sir?
Clear, sir.
But unfortunately, experiments have shown that beryllium chloride is a linear molecule. Both bonds have exactly same length and they have same strength and their angle is exactly 180 degrees. It is a linear molecule. So the formation of beryllium chloride could not be explained by valency bond theory. Fine?
Got it.
Hello?
Yes, sir.
Yes, sir.
Let us look at the formation of water using VBT. Oxygen is the central atom whose configuration is 1s2, 2s2, 2px2, y1, z1. So this is 2p y orbital, 2p z orbital of oxygen that have unpaired electrons. When they overlap with the hydrogen s orbitals, you got H2O. It is sigma sp bond. In water, what is the angle between these two p orbitals, sir? What is this angle? What is the angle between py and pz orbitals?
90.
90.
So the water HOH angle is supposed to be 90 degrees, but experiment has shown it is 104 degrees 31 minutes. Therefore, formation of water and its bond angle could not be properly explained by valency bond theory. But this is the first successful theory to apply Schrodinger wave equation to chemical bond formation. It tried to explain the formation of bond in light of quantum mechanics, but it failed to explain the bond lengths, bond strengths, and shapes of molecules. Okay? Okay, sir? Okay. Now, hybridization theory. The VBT was explained by Hitler and London. Hybridization theory was explained by Linus Pauling. Hello? Hello?
Sir.
Now, what is this hybridization theory saying? If I am looking at beryllium whose configuration is 1s2, 2s2, in excited state it is 1s2, 2s1, 2px1. It can go to 2p/1 or 2pz1, all p orbitals are same. Now what, according to hybridization theory, the s orbital and p orbital, 1 2s orbital and 1 2p orbital of beryllium intermix. How many orbitals are intermixing, sir? How many?
2.
So you are getting they form 2 sp hybrid orbitals. Number of hybrid orbitals formed is equal to number of atomic orbitals intermixing. And all hybrid orbitals are identical. These have 50% S character and 50% P character. They are identical. They arrange themselves as far away as possible. Sir, if you have two sticks, if you have to arrange them as far away as possible, how do you arrange? You arrange them at 180 degrees. Linear, yes. So these are two sp hybrid orbitals, 50% s character, 50% p character, separated by 180 degrees. It has one unpaired electron, it has one unpaired. The hybrid orbitals effectively overlap with other orbitals, maybe pure or hybrid orbitals, to give sigma bonds. In beryllium chloride, the sp hybrid orbital of beryllium overlaps with a Cl-sp orbital and another Cl-sp orbital. So in BeCl2, both bonds are sigma spp bonds, and both bonds have equal length, equal strength, separated by 180 degrees. Thus, the hybridization theory could explain why BeCl2 is linear, why both BeCl bonds are identical. So the hybridization theory says an atom offers as many hybrid orbitals as is its valency. If the valency of atom is 2, If the valency of atom is 2, it offers how many hybrid orbitals, sir? How many? How many?
2.
2. The type of hybridization is called sp. And how they are arranged? They are arranged linearly with a bond angle 180 degrees. If the valency of an atom is 3, it offers 3 hybrid orbitals called sp2. They are arranged like trigonal planar with a bond angle of 120 degrees. If the valency is 4, it has to offer 4 hybrid orbitals. The 4 hybrid orbitals can be sp3. If they are sp3, they are like tetrahedron with 109 degrees 28 minutes. Or it can be dsp2. It may use a d orbital, 3d orbital, 4s, 4px, 4py. Then these are like square planar. They are at a 90 degree separation. If the atom valency is 5, it offers 5 hybrid orbitals. They are called dsp3. It may use 3d, 4s, 4p orbitals, or it may use 4s, 4p, 4d orbitals. The dsp3 orbitals are like trigonal bipyramid. If the valency of atom is 6, it offers 6 hybrid orbitals called sp3d2 or d2sp3. They have a shape like octahedron. The shape of hybrid orbitals of central atom decides the shape of molecule. Notice, always hybrid orbitals make sigma bonds. Are we very clear? Who will make pi bonds? Hello. Who will make pi bonds? Pure orbitals make either sigma or pi bonds. Pure orbitals have 2 options. They can make sigma or pi bond. But if it is a hybrid orbital, it makes only sigma bond. Are we clear about this, sir? Hello?
Yes, sir.
Please remember, if it is a hybrid orbital, it should make sigma bond only, no option other than. If it is a pure orbital, it can make sigma bond or it can make pi bond. Okay, sir? Notice, hydrogen has only one s orbital. It has no scope to make any hybridization. Hybridization is impossible for hydrogen atom because it has only s orbital. If I am looking at carbon has 2s, 2px, 2py, 2pz orbitals. How many orbitals it has? 4. If carbon is using 2s and 2px only for hybridization, I get sp hybrid orbitals. If carbon is using 2s and 2px and just 2py, anything, I get sp2 hybrid orbitals. If carbon uses 2s, 2px, 2py and 2pz, all for hybridization, then I am getting sp3. Carbon has 3 options. If carbon is using sp hybrid orbitals, it is left with the 2 pure p orbitals. So it can make 2 pi bonds. If carbon is using sp2 hybridization, still it is left with 1 pure p orbital. So it can make 1 pi bond. If carbon is using sp3 hybrid orbitals, there are no pure orbitals left. It will make no pi bonds. Are we very clear, sir? Hello?
Yes,
Hello?
sir. Clear.
Hydrogen never makes
So should we rejoin?
hybrid orbitals. No, you won't rejoin. Tomorrow we continue. So far, we have discussed about hybridization. Okay, sir? Okay.
Yes, sir.
We will continue the talk on hybridization. In the meanwhile, you open the NCRT and read about hybridization completely. Tomorrow, we give
Okay,
a
sir.
final view of it. With this note, we close the discussion. Thank you very much. Have a wonderful time.